AI has officially outgrown the machines that build it. We have entered the Silicon Strait, a physical bottleneck where hardware limits and material scarcity dictate the software roadmap for 2027. This transition is moving the industry's equity from the models themselves to the physical supply chain. The crisis begins as we move to AI agents from chat-first systems. Agents operate in think, act, observe loops, creating a write once, read many worm data pattern. In these loops, the system reads from its KV cache the model's short-term memory of previous nodes about 12 times for every single token it writes. Because current hardware sits idle waiting for this data to stream from memory, GPUs achieve only 30 to 40% utilization on agentic workloads. To bridge this memory wall, the industry is pivoting to speculative decoding. This uses a tiny assistant model to guess token sequences that a large scientist model verifies in one parallel pass. This shift collapses latency from 45 down to 15 milliseconds. However, software efficiency eventually hits a hard physical ceiling called Reticle Limit, which is the absolute page size of a chip-making machine, the maximum physical area a single exposure can print, fixed at 858 square millimeters. Because next-generation chips like NVIDIA's Blackwell are now larger than that page, TSMC, the Taiwan-based world leader in chip manufacturing, must use CoWoS-L technology to stitch multiple massive silicon pieces together using tiny silicon bridges. These chips require high-bandwidth memory, a specialized architecture that stacks data layers vertically like a skyscraper, to read speeds 40 times faster than standard memory. Producing HBM operates on a 3-to-1 trade ratio with the wafer, which is the silicon disk used to print individual chips. Each HBM wafer produced for AI data centers removes the manufacturing capacity for 3 standard DRAM wafers used in smartphones or laptops. By late 2026, AI will consume 70% of high-end DRAM supply, triggering a projected 20% increase for consumer electronics. The ultimate gatekeeper is Ajinomoto Fine Techno, a Japanese company known for MSG seasoning. They're the world's sole supplier of ABF film, which is the insulating bridge that lets the chip talk to its circuit board. AI accelerators require 8 to 16 plus layers of this film, an 18-fold increase in material consumption per chip. If the seasoning company chooses not to scale production due to a fear of overcommitment, the global AI revolution hits a physical ceiling that software cannot bypass.